I'm Milo, and I'm going to talk about what the slide says.
What did it say?
Redux. I'm talking about Redux and Flux, which are front-end frameworks that are cool. So in real life, I have a name, and I study classics at university, and also code in my spare time a lot. And over the summer, I was working for Art Zero in Buenos Aires a lot. There's my stupid Twitter handle. Okay, so what the flux are Flux? I'm not the first person to use that pun. I stole it. If you're not familiar with Flux, it's not really a new idea, but it's been sort of rebranded and it's become a cool buzzword. So why not jump on the bandwagon? It basically is a way of building your application so that data only flows in one direction, which makes it a lot easier to reason about your code and debug your code, as I'll demonstrate. And you've probably also heard of React, which is generally used with Flux. It's what Facebook does. I mean, Facebook have been using it in production for a while, so it's all right. Facebook, I hear they've got a few users now. I mean, these are some implementations of Flux, because they don't actually come with React. React is just the view controller, I guess, as well, a bit of the library. I know some of them are right. I've used Marty, that's pretty cool. But I'm going to talk about Redux and basically compare it to Facebook's example implementation, because that's essentially like homegrown, so it's easy to understand. Okay, what the Flux are Redux? Redux is a new sort of take, like a refinement on the traditional, traditional, it's about a couple of years old, Flux setup. Basically, it simplifies it down to what it needs to be and tends to use functions instead of objects, which means you can do some cool stuff with higher order functions in debugging and development. And it makes it easier to understand what the code's doing, and we'll talk about that. It's very small, unlike some of the other Flux libraries, like Marty is not that small. So it's just 412 lines of code, and then you don't actually have to use it with React. I haven't seen anyone not, but it's really just a state tree, and then sets out some ways in the docs about how you should probably use that state tree in your application. So, I mean, you can do whatever you want. Have fun. So this is how a traditional store might look in one of those other Flux frameworks. Obviously it's different depending on the one, but basically it holds your state and is responsible for holding the state, and then it's a singleton usually throughout the entire application, and all of your React views subscribe to the stores, and then when the stores change they re-render depending on if they've got relevant properties, which is nice. And then Redux replaces stores with reducers, because it moves all of the actual state into the Redux tree, all into one place. And then the stores used to handle two things, right? Describing how your state should change when it gets sent into the store, and then actually storing it, because they're stores. But the reducer just is defined by its signature, which takes in a state and an action, and then, the simplest version is just a switch block. You can wrap that and do what you want if you don't like switch blocks. And then it looks at the action and returns a new state based on whatever happened. And then the same thing happens as in traditional Flux. It's an action, like in some of those Flux frameworks, actions are sort of weirdly wrapped, I guess, to save boilerplate. If you're just, you tend to have in Flux applications a lot of actions which are just like set variable x, and then action type set variable x, and then whatever your value is. So, you can make a function to return that if you think that's worth it, but the simplest way of doing it is just having a function which returns action object, which is standard throughout your application. how to use it with React. So you write multiple reducers, and then you use the combine reducers to put them all in one. And then basically what happens is whenever you run Redux, the store variable there, store.dispatch, it just runs it through all your reducers, and then you get a new state at the end, and that's passed into your components. So you wrap your entry in provider, and then all the state flows from there. Just pretty neat. Yeah, dumb components. Basically, this is like Redux recommended how you should use it. You split your application into components which don't need to know about Redux and components which do, which are these components' parents, as we'll see in a bit. And yeah, dumb components just render based on props, so they only need to update when those props change, and that's a really low cost check to do, so you should have as many dumb components as possible. Also, they're easy to reason with and really easy to test, because you just pass in different props and see if they render right on the page. Don't know about Redux, state is passed in parents. You can also bind action creators to the dispatch instance and then pass them in as props, so you can, like if there's a button in it or something and it needs to be bound directly to an action, it's probably cleaner than passing in, a wrapper function. I guess it's the same thing really, looks nicer. Smart in the node components, know about Redux. There's some snazzy ES6 code. That wraps your component class in another component, and then that function selects what state you want to pass in as props to that component. So here we get the state tree, and then we say we want to pass in important state.important data, because that's what this component needs to know about, and then this component will be re-rendered every time that state changes. Yeah. And then these components wrap your dumb components. Yeah, that's useful to have in a web application. So Redux has the concept of middleware, which is, like any sort of middleware. It's just a function that returns a function that returns a function. And you can dispatch multiple times within there, so it's kind of like half pseudocode, but you get the idea. If you want to have promises, then there's your action. That should say action creator probably, and it returns action of type amazing with a promise attached, and then in your middleware, which the action will get passed through before your reducers, you just check to see if there's a promise, and then resolve it if necessary. One thing which is pretty cool is if your types are just strings, then you can generate 3 different types of action. So here you generate started and success and failure. So you can catch those in your reducers if you want to catch errors and display them in the UI or whatever. Also, as with all Flux, it's nice to have one place where you can just console log errors in development. That saves a lot of time. Yeah, if you want to use the server side, it just looks exactly the same as the client. You create your reducers, apply your middleware, render whatever you want to render after doing some routing, figuring out your actions, getting your data, and you can send off that data as a bundle to the client somehow, however you want. And then when you instantiate Redux on the client, you can hydrate it with the state from the server, which is nice if your customer might not have great internet, because you can bundle it all before sending it. Any party tricks for debugging? Natural question. Yes. One of the cool things about Redux, since the reducers are just functions, is that you can wrap them in other functions and do things like make an easy undo button for your app, or it's more useful in debugging, as we'll see. They're also really simple to test, because you can just create artificial state and then send it in and see if it comes out how you expect. Can I make it bigger? Quite possibly. I mean, yeah, that's good. Okay, so here's the Redux debugger, which is pretty cool when you use it in development. So this is just the basic to-do application, which everyone is obsessed with. And you just do, and you see the actions are being added at the side, and then you can selectively remove them from wherever they are on the tree, and it'll evaluate the state as if it happened. And when you don't care about it, you can commit it and do some, sweep that away. Also, a change in real time when you're developing, so you can do something like have a look at a reducer. It's a real world reducer. It's pretty exciting. So here the state is just an array. You'll notice that it's returning a new version of that array every time. That's easier if you have immutable, because then you can just do something like .shift and that just thing, and that will just return your new state without this strange spread code. But that's pretty clear. So if you change that to say that, and then they'll come through with that. So this is pretty fun. Like, you can inspect your state. Another thing is it can persist for you if you want. So you just do query debug session and get one. So this one I made earlier, and then once you edit it, it'll persist across reloads. It's just saved to local storage, which is pretty neat. You have a bunch of scenarios you want to test straight away. That's often quite annoying as rerunning sets of actions. Like, if you are lazy and don't have proper unit tests, then that's useful. I think that's pretty much it. That was probably really quick. So, if anyone's got any questions, please ask and I will try to answer. Yes?
Do you have any rule of thumb on kind of how many times you pass something down through components and make them smart instead?
No. Once you wrap it in provider, you can just use connect anywhere in the tree.
Do you do you try to limit your number of smart components?
Yeah. I try to limit to, basically as shallow as possible. I think generally in development, you don't really need to go that deep because it tends to be a bunch of, you'll see in the example, this to-do example is just from the DevTools repo. He's actually got a containers, which is separate from components, so those are smart components. And it tends to be just a few smart components, and then you pass the relevant state selected into that box, and then you've got how many little components in there you want, because little components are easier to manage and faster if you do the shallow check. So yeah, be as shallow as possible in life. Any other questions? Nope. Okay. Well, I hope you enjoyed my presentation. You can check out all this stuff. I'll tweet the slides out later. Cool. Thank you for putting up with me.